Hello guys, in this video we are going to see this project and explain it all. This is a very fun project to create, but it makes you learn most of 2D basics inside Unity. So let's see the project. This is a character controller with a patrolling platform, swapping platform as you see, and some spikes, traps, and death. You might see this as overwhelming, but it takes only very little lines of codes. I'll explain all the codes and provide them also in a link in the description. This is super easy to make and won't take much time. So let's go to the hierarchy. Here we have the main camera, which is just an orthographic camera with a rendering of a default setting without post-processing. The environment is just not a skybox but a solid color, a black color. You can change colors whatever you like. This is just debugging colors. We have a global light 2D because this is a URP project. Managers, we have the dev manager only, which we will explain the codes later. We have a level, which consists of a ground, which is just a cube with a box collider and a layer of ground, and the player. The player here have a rigid body, a capsule collider, and a decent player movement script. It's not the best, but it has most of the basics. Obstacles, here we have a swap platform, which are platforms that swap between each other, and a patrolling platform. And in enemies we have the trap handler, which consists of just the trap and the trap trigger, and we have the spike handler, which just consists of some spikes. So let's explain everything. Let's start with the most important thing, which is the player movement code. As I said before, this is an intermediate course, not a beginner course, because if you are a beginner you will get very overwhelmed. So it's just a symbol, around 200 lines of code. So let's explain it. The player movement consists of parts. The first part is the variables. This is just variables that we will use then in code. We have floats, movement settings, which consist of move speed, acceleration, deceleration, and air acceleration multiplier. I tried commenting out most of the things just so it would be easier to change when you are working with the code that I provided. Here the move speed is the maximum horizontal speed, as we explained in the movement episode of this course. Here the acceleration rate, because to get a very smooth character controller or player movement you need acceleration, also deceleration. So here's the acceleration rate that I put the values inside my game is quick, and the deceleration to mimic around the Celeste vibe. Air acceleration multiplier is reducing the acceleration in the air, because when you are in air you cannot move as the speed as when you are in the ground. The jump settings are a bit important because we have jump force, chaos time, and jump buffer time. The jump force is the normal force that we are applying on the vertical axis. Chaos time is for gameplay. It makes a time after the jump from the ground to it's around here less than a quarter of a second that he can jump even after leaving the platform. The jump buffer time, it's a time window to queuing the jump. It's very easy, but these are all basics that were literally used in Super Mario Bros. Latent time. So they are not something very complicated. The ground detection, we have the ground check, the ground radius, and the ground layer. The dash setting, we have only the speed and duration. Other private variables are the rigid body, because here we are using physics, is grounded, chaos timer, jump buffer timer, is dashing, move input, and is facing right or not. This is for the sprite also and for dashing. In the start method we just call the component of the rigid body, and I usually call rigid body RB. In the update method we are handling all the functions. In the fixed update we are handling the functions that are related to the rigid body or the physics system. So we have here the move player and checking the ground. Handling the input is pretty simple. We are just saying move input is equal to the Input.GetAxis horizontal. This code only captures the horizontal input, which is the right and left. The vertical input is a bit different because we will need a if statement for it. We will see the Input.Get button down, not just get button. When it's pressed down, the jump, and that's for jump buffering. Then we will calculate the jump buffer time and make it equal to jump buffer time. In the dash input, we will also see the get key down of the key code left shift. The difference between a key down and a button down. Button down, you can change it from the settings inside Unity Input Manager. Here you are calling the key from a keyboard. You could also go to the Input Manager, name it something instead of jump, like name it dash and use the Input.Get button down. But here, for making it a bit easier, we are getting key down, key code left shift. But of course, this is just a tutorial. When you are working with the industry standard game, you need to really focus on the inputs and reading if there is a controller, or he is playing on a mouse and keyboard, or if he specified a special controls or not. And yeah, so we are talking here just a basic project to keep things in mind. And then checking that he is not dashing already, so he do not dash multiple times during one dash. And here the dash is a quarantine. As you remember, in the second episode we explained that calling a quarantine is different from calling a normal functions. Here a private function of checking the ground. This is super easy. We are just using the physics 2D library inside Unity to overlap an imaginary circle, and the radius of this circle is just like a ray casting to check if the layer of the of this circle is ground, and if the position of the ground check is in the overlap of this circle, then he can jump, and if it's not, then he cannot jump. So he can so we fix the problem that many people face, which he can jump infinitely. So we check ground in this very simple function. Handling queue time, you can reset the queue timer if it's grounded, and otherwise decrement. So it's super easy. You check if it's grounded. If it's grounded, then queue timer is equal to the queue time. When you are equaling something to itself, you are resetting it, just like resetting the jump buffer timer here in the jump function. So here he is resetting the queue timer, and if not grounded, we are decreasing it by time.delta time, or making it just like a stopwatch. Then going to the handling the jump buffering, execute the conditions as the comment says. If these conditions are met, if the jump buffer time is larger than 0 and queue time is larger than 0, then jump and jump buffer time equal to 0. This is resetting the jump buffer inside the handling jump buffer system, and then else decreasing it just like the queue time. It's very simpler. It's just calculating the queue time if it's larger than 0 or not. Now to the move player, which is a very also simple code. Here we have the target speed, which will be equal to the move input and multiply it by the move speed. If you remember it well, we talked that the speed is just jumping from numbers on the coordinate plane. If you want, you can revise the episode 1, and we are multiplying it by the move input, which is defined here to be equal to the Input.GetAxis horizontal. So this will give us the target speed. Calculate the speed difference. The speed difference equal to the target speed we did before, and minus it from the velocity of the x-axis to make the base of the acceleration and deceleration. Then to determine the acceleration rate, we make a float of acceleration rate, make a math f absolute value. The math f lab absolute value function is just making sure if it's minus or positive, it will always give us the value of the target speed. Just like in math, it's a math library inside Unity, have many functions. Most used is the absolute value, and then making sure it's larger than 0.01, and if yes, checking. This is an if statement, but it's like written in another way, checking if it is grounded, then acceleration, is multiplied by the air acceleration multiplied. This is L, so this is F, and then the acceleration. See, this is a very complicated way to put in an if statement. You can read it in Unity documentation, but it saves a lot of time in writing code. If you don't want it, you can just use the normal syntax of an if statement, but this is I put it like this way just to explain for you guys that not getting confused when you read a lot of codes like 1000 2000 lines of code. When you see these marks together, it's usually an if statement, so don't get confused. Then the velocity change, we will use the clamp value, which is clamping all of these together. MathF library, you can you know what, I'll make an episode for it, just like Delta time. Forget the Unity documentation, it's a bit bad in explanation of this stuff. So speed differences and taking the acceleration time and multiply it by time and the acceleration rate we also did before, and now multiplying it by time.fixed delta time. Then update the rigid body velocity. These all could be, by the way, these all for the acceleration and deceleration. If you do not do acceleration and deceleration, it would be just 2 lines of code. But yeah, it's important to give the player a smooth gameplay, especially if it's a platform game. It's the most important stuff. Then the simple jump function, which just adds on the y-axis the jump force, and then the variable jump, which it's reading the input and then lower the multiplier for sharper cuts. So it's getting the input of a jump, then going to rb.velocity.y and checking if it's larger than 0, then rb.velocity equal to new vector 2, which is checking also if rb.velocity.y and multiply it by 0.4 to lower the multiplier for sharper cuts. The dash iometrator, as we said, this is a quarantine. It's easy. We check if it's dashing. Then disable gravity during dash. This is important because dash would not work with the gravity. That's why you can't dash in real life. And then applying the dash velocity to the x-axis, of course, and then wait for the dash duration. Of course, you can, as I said, this is a very simple code. You need to also calculate the angles in dash if you want them to dash upwards and in different directions. So of course, this is a very simple code for player movement. And here we have a very simple flip player code, which is at this rate everyone uses it. You just multiply the x scale by -1 when he is facing right. And here we are drawing the gizmos for the ground check. So this is the player movement code. Extremely simple and is not very complicated.